Okay, good afternoon to all of you. There's a little bit of technical hiccup here. Finally, the button for sharing the screen appeared. Okay, just to confirm, can you all see the screen with the notes and hear me as well? Okay, and thank you very much. So, okay, I will get started. Yeah. So if there's anything, please speak out to stop me because I won't be looking at the message from now. Thank you very much. Okay, we do a quick recap of the last lesson when we started on AC. Okay, for the benefit of those who may miss the lesson, or if you may not have listened to certain part of the lesson. So I'm going to do a very quick recap for AC circuits. Okay, we started this topic by looking at the so-called AC waveform or sine wave. All right, we call it a sine wave here. Okay, in long term we call it sinusoidal waveform, but most of the time we call it a sine wave. Okay, so basically the sine wave, as you see, you have two halves. One is a positive half, and one is the negative half. And of course, that goes to what you call that alternating current or voltage. Okay, which means one moment is a positive half, the next moment is a negative half. So that's how the alternating word came about. All right. Okay, that's why this is a waveform or a sine wave or AC. All right. Now, we started off with looking at two things which is important. We talk about the amplitude. All right, amplitude or one half only. Be careful. One half of the waveform here. Okay, we call it an amplitude. For example, amplitude can be a voltage of 10 volts, 15 volts, or whatever. Okay, the value about here. Okay, the value that is so far given here. Example 10 volts. Okay, that's your amplitude. All right, example. Okay, then another important thing that you need to know about sine wave is, of course, this one, which we call the period. All right, capital T denoted by capital T. Okay, the period means full cycle, the time taken for a full cycle to complete. Okay, hold on, I'm going to do something first. Okay, come back. Okay, so one more time, the T, capital T stands for period. It's the time taken for a cycle to start and end. And here. So it's one complete cycle. Okay, one positive half and then one negative half. So this time taken to complete that is called period and denoted by the capital T. Okay, I move on. So before I move on, this is important as well. Please take note. This is a generic or general formula of a sine wave given. Whether it's a voltage or current is the same, right? You have this general formula. Okay, then we move on. Then we talk about how to find frequency. I mentioned if you want to find frequency, I think it's better to put capital F here. Okay, you just use a simple formula 1 over T. All right, and then you find frequency in hertz. Okay, frequency, all you know the unit is hertz. Correct? And similarly, or rather, if you want to find T, you just do the opposite of the frequency. Instead of 1 over T, is 1 over F. All right, and then you find the time for one cycle. Okay, that is the word here, one cycle. That's how I mentioned, time to complete one cycle. Yeah. Okay, amplitude just now I mentioned to you. Sometimes we call it the maximum. All right, sometimes we call it a peak. Both mean the same thing. Sometimes we use the word Vm to denote Vmax, and sometimes we say V peak. Okay, Vp. P. Okay, both meant the same thing. So don't get confused, just to clarify. Okay, then we move on, and then we start to solve problem using the sine wave formula. Okay, first this is what is given. All right, then you write it down, and then of course you compare it with the general formula, and that's how you get this part. Okay, which is exactly here. Okay, sine 2 pi f is actually this whole thing. All right, 439.8. Okay, that's why they write it this way, and that's how you solve your frequency. Okay, once you have frequency, you use a simple formula t equals 1 over f, you find your period or time. Okay, so it's not difficult. Then further down, we ask to find the instantaneous voltage at certain time. Very quickly, instantaneous voltage means, example, I draw the waveform first. What does it mean? Okay, your waveform will move like that, right? So instantaneous means at certain time, there is a certain value of voltage on the sine wave. Example, at this time here, I have a voltage here at this point. So I cross it out. Okay, example. Example, you find that this is 0.2 second. Example, so, okay, sorry. Example, this is 0.02 second. Okay, this time. And then you have the instantaneous voltage at this level. And then further down, you say, I have another time at 0.012 second. Maybe it's somewhere here. Okay, example. And then if I project down to the waveform, then I say this point here is the instantaneous voltage. Okay, at this point, at this time. So this 0.012 could be this time here. Yes, example. So do you understand? So that is the meaning of instantaneous voltage. As different time, different point of voltage. Okay, because it's moving, this is the time here is moving. Okay, so different timing, different point of the voltage. That is the meaning of instantaneous voltage. Okay, just to highlight again in case you are not sure. Any question first? Quick one before I move on. Any question? I'm doing a very quick recap. Hopefully you have a question you can ask me. Anybody? Any? Okay, Ken, thank you. So I move on. All right. Then we talk about the mean value or average value. All right, how to get that. And we just use a simple formula to calculate mean value. Either you calculate current or calculate voltage, you still use the same so-called formula, meaning that we multiply by 0.637 Im, Imax or 0.637 Vm. All right, so that is how you find the average or mean value, okay, of the sine wave. Okay, the next thing that you want to know or important for you to know is the RMS value. Okay. Okay, that day I did mention RMS value or root mean square means true value. Okay, the very effective value. All right, here is given again by a simple formula. You use 0.707 multiplied by the Imax or 0.07 multiplied by the Vmax. Okay, whether you find current or voltage, you still use 0.707. All right. So if you put just down these two values in perspective, it looks something like this. Let's say I draw a waveform. Okay, let's say this is my Vmax. Okay, this is my Vm. Example, now I'm talking about voltage, Vm. All right. So if you talk about RMS value, they say that is 0.707 of the VM. That is the RMS. So you can say that it's about 70.7%. Okay, around here the value example. Okay, this will be the VRMS. Okay, I'm talking about voltage. Don't worry, same thing apply for current. So I'm using the voltage as an example. Okay, so you can imagine that this is the value here. Okay, after you multiply whatever VM value is. All right. Ken, any question? And if I move back to here, just now earlier on, they say 0.637. Yeah, for the mean value. So you can imagine the mean value is slightly lower here. All right. And then you use 0.637 times VM or 63.7% of VM. So this one is, imagine, will be your V.
Hello. My name is Afiq and Anik. We just joined.
Okay, this will be your V mean. Okay, Ken? Ken? Are you okay? So basically, it looks like that for the two value, V average and V RMS. Okay? Any question? I'm doing quite a quick recap. Of course, later you have question, you can still ask me. Any question before I continue a bit more of the recap? Anything to clarify? If nothing, then I continue from there. Okay?
You are
Alright.
unmuted.
Okay, then we move on from here. I think I have started on this part. For the theory resistive circuit. Okay, first thing first,
Hello?
you look at this circuit. There's only a resistor.
Can you hear me? Hello.
Okay, one component here only. The supply is still AC here. AC. I think you see the symbol there.
My audio got problem. Can anyone hear me?
Alright. So from here we look at the phasor diagram, rather the waveform, voltage and current. Okay. If you look at this diagram here, waveform, you can see that the voltage and the current are in phase. All right. When they say in phase, what does that mean? Okay, look here carefully. I start and end at the same time. Okay, so voltage and current are in phase. Okay, so yeah, that's how you explain. They start and end at the same time. Okay, that is for the resistive circuit. All right. There is another way to look at it. I'm looking at a phasor diagram, but then I feel that this waveform diagram is more helpful. Okay, to identify which is leading or lagging later when we come to inductor and capacitor.
Ethan, shut up. Ethan, shut up.
And
Check it.
Yo.
okay, then of course the ohm source still apply here. All right, when you want to find the current, all right, V over R, you can still apply here, but of course you make sure that they are all RMS value because we are talking about AC here, right? Okay, just now already we went through this formula. Okay, both for current and voltage the same. You want to find RMS value, you multiply by 0.707. Okay, then you'll get the RMS value. Okay. All right, then now we go on to some example here, which we did last week, I mean the last lesson, yeah. Okay, RMS value of the current is given as 5 amp. All right, the voltage is given in this general
Hello, can anyone hear
formula.
me?
Okay, so of course, they ask you to look for the resistance. But before that, the important thing is convert the voltage to RMS value. Okay, this is VM. This is VM. It's not RMS value, this is VM. Right. So if you want to convert it to RMS value, you have to multiply by this. Okay, and where this value comes from is actually this one, same. This is VM. Okay, this is VM.
Assalamualaikum.
Right.
Everyone tengok khabar.
So when you multiply by 0.707, you will get 10 volts. All right. Now be careful. I repeat. The voltage has to be in RMS value because your current also in RMS value here. So that's how you get 10 divided by 5 and then you get 2 ohms. Okay? This is what we went through last week. I hope you are pay a little bit attention to this so that you can understand it. It's not difficult. Then, we went on to talk about power in resistors. All right. Okay, basically there are 3 formulas. All right. One is VI, one is V squared over R, and then is the other one is I squared over R.
Hello.
Okay, all 3 formulas can be used to calculate your power. All right, depends on what is given to you. Okay. Yes?
Hello, teacher. Can you hear me?
Yes.
Yes, can hear.
Sure. Yes, any question? Thank you. Any question?
No question. I got one question to the fat fuck inside the call.
Thank you. Okay. Let's continue. I think we check a bit more because we cover until the resistor.
Hello.
Capacitor.
Okay, so you go inside.
Okay, we move on to the next one, which is purely inductive circuit. All right.
Return.
Now you only see the
Don't
inductor.
interrupt the teacher lah.
Right. As I mentioned, I would want you to refer to this side, the waveform diagram. Okay, now for inductor, you realize that the current waveform start later. I use the word later. The voltage start earlier. Okay, the waveform of the voltage start earlier and then followed by the current. Okay, in this case, we use this to describe the current lags the voltage by 90 degrees. Okay, why 90 degrees? Because we are exactly here, all right, 90 degrees. Okay, 0 to here is 180, and half of 180 is 90. Okay, so from here, then the current start to conduct or start to waveform. So it lags the voltage. Okay, so this is a way to describe the inductive circuit. All right. Then any question? If no, I will move on. Okay, just now in resistor, there's a power that you can calculate, but for inductor circuit, there is no power dissipation. Average power is 0. Why? Because inductor is, when current flows through it, the magnetic field will build up. When there's no current flowing through the inductor, the magnetic field will collapse. So there is no power dissipated. Okay, just to take note. Okay, yeah, because they are basically building up a magnetic field and then collapsing when no current flows. Okay, again, we move on to the next one before we start something new. Okay, the next one, the third one of the 3, you only can see the capacitor in the circuit, which is a purely capacitive circuit. Okay, again, now we look at the waveform diagram to understand what is the difference from the inductive one. Okay, now you see that the voltage started here, but you realize that the current waveform for capacitive circuit actually started earlier. They didn't draw, so I just draw. So I just draw a bit example. Okay, example. So it started earlier, right? It started earlier before the voltage waveform start. The current start first. So that is the reason why they say the current leads the voltage. Okay, again by 90 degrees. Okay, just at this point is 90 degrees. All right, and that comes out. Then, So the current waveform starts first, then followed by the voltage waveform. And that's how you describe it. The current leads the voltage by 90 degrees. Okay, Ken? Any question? And then, of course, same as inductor, the average power is 0. But now what happened is different from inductor. Inductor is magnetic field. Remember I told you, inductor, when current goes through, it builds up a magnetic field. But in capacitor, I think some of you already know, it's like a battery. The charges will start to store when you charge a capacitor. Yes, it stores charges. But when the current stops going through the capacitor, the charges will start to discharge. So there is no power dissipated. Okay, that's why the average power supply to capacitor is 0. Okay? Then, any question up to here first before I move on to the rest of it? Any question, anyone? Before I move on to the continue with the topic first. Okay, no question, then I will continue first. Thank you. All right. Now you learn something new this afternoon. Something new means the word reactance. Okay, what is the meaning of reactance? Okay, in a resistive circuit, we call resistor. In DC, we call resistance. But in AC circuit, we call it reactance. All right, just take note of it. But the unit is still the same, it's ohm. Okay, but the symbol is different. Okay, it's X. This one stands for reactance. Okay, can you take note first? Okay, first thing first. So for inductive and capacitor or inductor, you have resistance, but the resistance you don't call it resistance. We call it reactance because it's an AC circuit. All right. And so I move on. So we start off with the inductive reactance first. First thing first, this is the symbol. All right. Okay. It is just like resistance in DC circuit. Okay. Just that now it's in AC. All right. Then ohm. All right. Although it's named differently. Or it's that one you call in resistive, you call resistance, here you call reactance. Right? Now, please take note, no choice. This is something they can test you in the exam. All right, there's a formula to calculate so-called inductive reactance. Okay, given by 2 pi F and L. L is the inductance. Okay, the unit is in Henries. Okay, the rest is simple. F is still in frequency, hertz. All right, 2 pi is 2 times pi, pi is 3.142. Okay? Okay? So this is the graphical illustration of the reactance versus frequency on your right hand side here. So please take note of this formula because further down we have example how to do some calculation. All right? Can. Okay, maybe just take note one more sentence here. They say it's proportional to the frequency. That's why there's a graph that depicts this way. That means if the inductance or inductive reactance increase, the frequency will also increase. Okay, that's why they say proportional. And then if the inductive reactance goes down, the frequency also goes down. Okay, that is the reason they put it proportional. Okay, so you go by the graph here. Okay, then okay, good. Now we can go to an example to see what kind of question we can be asked in the exam or some calculation. Okay. Wait, I pause for a short while and just ask any question from anyone before we start the example. Any question? Anybody? Any question? Can you all still hear me? I think my background noise is a bit noisy, but can you all still hear me? Oh, okay, thank you, thank you. All right, if no question, we go through the example. All right, example 3 first, huh? Okay, a pure inductor having inductance of 50 millihenry. Okay, supply, of course, they give, this is a formula for your AC waveform. Okay, 8 sine 314 volts. This is the general formula for your voltage of a AC sine wave. And then they ask you to find the inductive reactance. Okay, just now the formula, let's revisit, which is the formula here. This is the one, right? XL equals to 2 pi FL. So we just have to use this formula to solve example 3. Okay, so it's the same thing. We write out or rearrange everything. You can see finally it's 314 divided by 2 pi, and you get, first of all, you get the frequency. Correct? Because your formula here needs to find the frequency. And then that's why you have to use this to find the frequency first. All right? Ken? Any question? Anybody? All right. So after finding, then I can so-called substitute this value inside frequency. Yeah? Correct? Which is over here, the 49.97. Yes? Okay? Then the 50 millihenry is coming from here. Okay, 50 times 10 to the power minus 3. And then, of course, you finally get the answer, 15.7 ohms. I pause for a while because I'm not sure you all can catch this part under the frequency. Any question on that part? Just go back to the main. Any question? Hi, good afternoon. Any question for the example? Anything you want me to clarify?
Okay, your screen start to good afternoon.
Oh, thank you for telling me. Thank you very much. Let me go back. Sorry about that. Okay, I share one more time. Okay. I hope you can see now. Okay. Okay, any things you want me to repeat or clarify for example 3? It's okay one. I mean, I can repeat. I mean, if you feel that you want to be clear about it. Anyone?
Can you repeat from the start?
For example 3, is it?
Yeah.
Okay, I start now. I erase all the linkers. Okay, hang on. I go back to my big screen. Okay. Let me clear away all this first. I start one more time. No problem. Okay. First, we read the question. We talk about an inductor, right? First thing. So inductor, the unit for inductance is Henry. So given is 50 millihenry. Okay, when we read question, we see what is given first. Then we try to solve. Okay, inductance given at 50 millihenries. Okay, then they say the supply is given by this formula. Yeah. Okay, if you have forgotten, I just bring you back. To the general formula again of the waveform that we started with right from the beginning. It's okay. I'm going very slow. Don't worry. I'm going very slow so that it's better for you to be clear. Okay, then we are here. Sorry. We are here. We come back to here actually. Yeah. So this is a general formula for a sine wave or AC waveform. For this is voltage, for this is current, doesn't matter, both the same. So if Vmax sine 2 pi ft, right? Okay, this is a generic formula. Okay, are you okay with that first? All right, okay, okay, now I go back. I go back to here again. I try to write out the formula for you. Sorry, overshot. Okay, so just now the generic formula is what? V equals, pardon me, I'm not writing very well. So, Vn, the formula is like that, Vn, right. Then sine not easy to write here. Sine 2 pi f and t. Okay, sorry, I write a bit slow. Okay, this is the general formula that just now I point out to you. I wrote it here so that you can see. Now, of course, there are questions. Because some of you looked at here and then you find, hey, why suddenly frequency equals to this, like that? Okay, now I go very slow. You follow me first. Now, this is given. Yes? Okay, look at this part first. Can you follow me? 314T. Okay? Or rather the 314. Don't want to, let me erase. Just look at the 314 first. Okay? Now, if you compare this formula here, given one, the 314, which part of the general formula is it equal to? It's equal to here, right? Look here. 2 pi f. Don't bother about the t. Don't bother about t. I'm looking at 314 and I compare with the general formula. So I can say my 314 equals to 2 pi f. Wait, do you agree first before I move on? So that we are going in the same. Okay? Just now someone asked me to repeat. So can you all see it? Okay? Can you all still hear me? Sorry, just to confirm.
Yes.
Okay, thank you very much. So, any question for here? I'm sorry. Okay, so now can I just write out this thing for you so that to clarify this part, to clarify this part here, or how you come to here. Actually, it's written like that. 3, 1, 4. Okay, equals to 2 pi f. Yeah, it's actually written like that. Yes. So before it comes to here, it's actually this one first. So you look carefully, they move the 2 pi over. That's why they write it this way. F equals to 314 divided by pi. You understand what I mean? Okay, originally this is the first step I write I mean I say first step, or before I come to here, second step. Because the example here never show you the first step. So you may be blurred. Are you okay? I'm clarifying why here is F equals to 314 over 2 pi. Actually, it comes from here originally. And how it comes about, then I just show you. 314, you relate to the general formula, is actually 2 pi f. Right? So 2 pi f is here, 314 is here, equal. They are both equal. And from here, then we go and find the frequency. 314 divided by 2 pi. Yeah. Are you okay? All right. I think should be better if you see this first, then see this one. Right. Okay. Of course, then from there, after finding the frequency, because you need this frequency to come inside here to complete the whole formula before you find the answer. Okay. That is the reason why you need 5 frequency. Right. Because your original formula needs the frequency. Yeah. So with the frequency in, you can multiply everything together and then you get the answer. Okay? Any questions up to here? Any question? For example 3, if no question, we move on to one more example before we pause for a while. I know it's very heavy in the afternoon to do this. Okay, one more example before we take a short break. Okay, example 4, we are still doing inductive reactance. All right, given here is the inductance of 100 millihenry. Okay, again, and then the voltage, they give you the actual value of 5 VRMS. Okay, and the frequency of 51 hertz. And then, of course, they still ask you to find the inductive reactance. Okay, so those are the 3 things given. Inductance, AC volts RMS, the sine wave, and the frequency of 51 hertz. First of all, write down the formula. Okay, and then you substitute the values in. Right, but here, wait, they ask you to find inductive reactance and calculate the value of the current, also RMS of the current. Okay, so we settle the XL first as inductive reactance. So we have all the values that are given, we plug in 51 millihenry. All right, okay, and then we get the value of the inductive reactance, 32.04 ohms. Of course, then we use Ohm's law here. Okay, I equal to V over R, but this is not R because this is now inductive reactance. Okay, 5 volt is given to you, which is RMS value. Okay, from here. All right. And of course, the 32 is your inductive reactance, which you already found earlier on. Okay, and then you finally get your answer. Okay. Any question as of now? Any question? Anyone? Any question?
Sure. Don't need to use the sign.
Sorry again, sorry.
Don't need to use the scene.
No need. No need. As of now, no need because we based on what they are given to us. Or we substitute the values only. Yeah, good question. Yeah,
Okay.
we use the entire, I know what you mean, yeah. We make use of the substitution of the terms as of now. Okay. Okay, thank you.
Then we need to use the sign.
No, not at the moment. Not at the moment. Yeah. But even if you want to use, because unless all the values given to you, then you just sign the whatever value you find first. You know what I mean? Using a calculator. Yeah. Okay, Ken?
Can.
Okay, I think we pause for 10 minutes break now. I think it's not easy for you to absorb so many things at one go. So we come back in 10 minutes time, 3:10. Okay, Ken? All right, your answer, correct. That is the best check. I can't, no point I keep telling you, this is the formula, this is what you put. But if you don't use a calculator to do this calculation to confirm, then it's very tough. Right now, at least you do once and you get this answer, then you say, okay, I'm doing it on track. I'm correct. Ken, I only suggest to you, I cannot force you to do, but that will prepare you for your exams. All right, Ken? Okay, let's move on to example 6 now. Now, every time, even in the exam, a question given to you, important thing is take a note what is given to you first, before you start doing, okay? All right, current flowing to a capacitor connected to 100 volts. Okay, that's a voltage, and 50 hertz, that is a frequency. And then there is a current, 0.001 ampere. And then, of course, they want you to find the capacitance. Again, capacitance here, if you use Ohm's law, you can still do it. Okay, you will be surprised. I can use Ohm's law. Yeah, why not? Because the unit of SC capacitance reactance is still ohms, the XC here. All right, but what did I say? You have to be careful the value that you put in. Correct. So the voltage is given here 100, right? Come from here and over the current, and you get 100 k ohm. And that is your XC. Be careful. But the unit still is in ohms. Still in ohms. Okay. Why you need to find this? Simple. Because they ask you to calculate the capacitance. And you know that this formula, within this formula, you need to find here the C. All right. So you need to have the capacitive reactance. Yeah. Correct. To find C, because the frequency is already given at 50 hertz. That is the only unknown, C. That's the reason why you need to find C first. Then I can substitute inside here. I'll take the 100k and then put here. And then go on to solve the sums and get the answer here. Are you okay? Now this part is just about rearranging only. From here, it comes to here, it's just about rearranging the term. Okay, can? Okay, in other words, all the 2 pi f I bring over the other side and the xc over. Okay, switch over the xc and the c. All right, then when you come to here, you find c. You will 1 over 2 pi xc. All right, 50 given 50 hertz frequency. xc you found just now and you put in here. Yeah, substitute here. And then of course again you use your calculator and then confirm your answer. Okay, can I ask any one of you, what is the n stand for there, the small letter n? Can someone make an attempt to answer me? What is the small n there? Anyone? The small n there stands for what? Anybody? Can you all still hear me? Can anyone attempt what is the small n there? 31 point n farad. What is the n there? What is the small n there represent what? 31.8 small n farad. What's the small n? What's the multiplier there? Nano. Nano is what? 10 to the power of? Thank you, Sun Xian. Nano is 10 to the power of? Yeah, right. Thank you very much for the answer. Okay, the nano here is what Sun Xian given the answer, 10 to the power of -9. Yeah. Okay, Ken, thank you very much for the answer. Okay, Ken, so be careful of the units and all the multipliers there. Okay, or else if you miss out those you didn't write in, then your answer will be totally different, of course. Yeah. Okay. Any question up to here? Okay, if not, then we almost coming to this end part already. Okay. Okay, last but not least, we come to impedance. All right. So the symbol is a capital Z or Z, whichever you want to call it. All right. So it's basically a combination of all this R, L, and C circuit. Resistor, inductor, or capacitor. In other words, it's a sum of all the resistance and reactance. Okay? Of course, in resistive circuit, we call resistance. In the inductor and capacitive circuit, we call reactance. So this is the total of the three. All right, and we call it impedance. Sometimes we call it total impedance. Okay, in the AC circuit, okay, AC circuit, we call it impedance. Total resistance, we call it impedance. The unit remains the same because all of them are in ohms. Resistance, inductive reactance, capacitive reactance, all are in ohms. So that's the reason why the unit is still in ohms. Okay, any question from anyone as of now? Okay, thank you. If no question, I will want you to attempt the quiz in my connection. All right, let me share the screen where to get your quiz, and then you submit again.